We now consider an example where we've got a tank, a water tank, and we're given some information about the rate, which is in liters per minute, of the water flowing into or out of the tank over time. And if we look at our rate here, being 200 minus 10t, we could imagine computing some things like at t equals 0, the rate is going to be 200, which implies the tank is filling at 200 liters per minute. But of course that doesn't stay constant because there's a time value in our rate, and so as time goes on, the flow rate is going to go down, the inflow is going to go down, and it might even go negative. And so we're going to use the convention that positive rates mean flow in, and of course negative rates are going to imply a flow out of the tank. Alright, that being said, we're interested in this question: by how much does the water level in the tank change? There's our keyword. We're looking for a change in V for volume. And what have we been given? Well, we've been given R of t in liters per minute. Well, that sounds an awful lot like the derivative of the volume. If we know the flow rate, and if the flow rate's positive, the volume in the tank goes up. So let's be a little more precise here and recognize that this is the volume of water in the tank. If the rate at which water is leaving or entering the tank is positive, the volume is increasing, we're adding water, it's getting filled up. So R of t and the derivative dv dt are the same thing. What we can do with that is then use the net change theorem. We want the change in volume, and we just said in the last question that we can integrate dv dt, or if you like using the symbol, or v prime of t dt. We can integrate that, and after time 0 is where we start, and we're going to go for 45 minutes. And the units, again, a quick check, liters per minute. These are in minutes, and time then would be in minutes as well. When we multiply that out, we're going to get liters, which is a perfectly good choice for a change in volume. How many liters have we gained or lost? And now we're good to go. We have our integral, and we have a formula actually in this case here, so we can actually evaluate this integral. So leave off the t's here. Our rate of change is 200 minus 10t, all that in brackets, dt, and courtesy of the fundamental theorem, we can now apply or find this value by taking an antiderivative. So we get 200t, integral of 10t would be 10t squared over 2, and using our nice vertical bar notation, we're going to sub in the 45 and the 0 later, but this gives us the antiderivative as one step of our calculation. Then we go one further step, we plug in the 45, minus, I guess we could simplify that a little bit. Let's call that 5t squared. So minus 5 times 45 squared. In terms of the fundamental theorem, this is our integral from a to b is equal to our antiderivative at b minus the antiderivative at a. So here's our f of b done already. We're going to subtract this whole value at 0, which turns out to be 0 and 0. That's nice. And we can just pull out our calculator here and figure out the value. And we get 11,250 liters. And we have a negative value overall for this. So that's an interesting change. But again, if we look at the rate and how we interpreted that, as time gets bigger, the rate is eventually going to go to be negative, 200 minus a bigger and bigger number. And if the rate is negative, that translates to flow out of the tank. And so what this translates into is a simple loss of 11,250 liters from the tank. Over that time frame, the tank had some water, and it would have gained some initially, it would have filled up, and then it would have ended up draining out, and at the end of the 45 minutes, we would have lost an accumulation of 11,250 liters. Now, of course, there's a quick assumption we have to make in this, that we must have had that amount or more in the tank at the beginning of time, when we started counting from time equals 0. If that wasn't the case, then this integral wouldn't make quite as much sense. We'd be violating some laws of physics by trying to put out volume that didn't exist. But with that caveat that we could have had any amount, as long as it was larger than 11,250, then we could have proceeded with this example, and we would have found the amount net change in the tank water level over those 45 minutes.